Hello, everyone. Today we're going to continue graphing systems of inequalities, only now we're going to look at more than just two inequalities, linear inequalities. What I have posted, if you didn't already read in the post in Classroom, I have a PDF of this. So if you prefer, you could print this out and just follow along, and there's less writing involved this way. So you can pause the video now if you want to go ahead and print that out. Maybe you already did. So let's continue then. All right, so for example 1, we're going to graph the solution set of the following system of inequalities. All right, so anytime we see an x and a number, that's going to be a vertical line. And this is actually just the y-axis. It's going to be a solid line. I'm going to use purple for this one. So let's go ahead and just draw a vertical line. And that's for x is greater than or equal to 0. So when we go to shade, we're going to shade to the right of it. So I'm just going to show like little arrows. So when I go to shade, I know I'm going to shade to the right of it. Y is greater than or equal to 0. That's a horizontal line. I'm going to use blue for this one. It's another solid line. So here's y is greater than or equal to 0. When I go to shade, I'm going to shade above, just to draw some little directions. So I knew that ahead of time, which is why I just stopped with the purple, but if not, we know we would shade to the right. But now that we have to stay above the blue, these two pieces right here don't even matter. We're not going to shade below the blue line. Now what I'd like for you to do, we have to take both of these next two inequalities and put them in slope-intercept form. So you guys go ahead and do that. Pause the video if you still need more time. So looking at the first one, we have to subtract 2x from both sides, so we'll get a 5y is less than negative 2x plus 10. And then I'll divide everything up here by a positive 5, and because it's positive, I don't have to flip the inequality sign. So we're going to get y is less than negative 2/5 x. 10 divided by 5 will give me a 2. And then over here, I'm going to subtract 3x from both sides, so we'll get 4y is less than or equal to negative 3x plus 12. Divide everything here by a positive 4. Again, we don't have to flip the inequality sign, so we'll get y is less than or equal to negative 3/4 x. 12 divided by 4 will give us 3. Now, the inequality in red is going to have a dotted or dashed line because the inequality sign here is just a less than. And the one in green is going to have a solid line. So let's go ahead and graph the one in red. My y-intercept is at a positive 2. My slope is negative 2/5. I'm going to move down 2 and then over 5. I don't really need to go anything below that, but I could also go up 2 over 5. But because I have to stay in between, we could use a ruler, but just to help me draw my line, I'm going to show it this way and this way. Remember, it's a dashed line. And we are going to shade below. So I'm going to be shading on this side. And then my green line starts at a y-intercept of 3. I'm going to count down 3 and over 4. And this is going to be a solid line. And I'm also going to shade below. All right, so if we take a look, we have to shade to the right of the purple line, above the blue line, and below both the green and the red. So that's going to be everything right inside here. But I can only go up to my green line. So it doesn't create a triangle. It is a four-sided figure, so a quadrilateral looking right here. So this area in yellow is the solution region. It's where all four shaded regions overlap. So essentially, this is what we're looking at. Anytime we have more than two lines intersect, chances are they're going to form some sort of a shape, a polygon. Most of the time, if we just have three inequalities, it's going to form a triangle. If we have four linear inequalities, chances are it's going to make some sort of quadrilateral. In this case, the x and y axis helped. Now remember, you can always test a point. So maybe if we tested a 1, 1, we definitely know x is 1 is greater than 0, y is 1 is greater than 0. 2 times 1 is 2, plus 5 times 1, 2 plus 5 is 7, which is less than 10. 3 times 1 and 4 times 1, that's 3 plus 4 is less than or equal to 12, less than 12 for sure. So we know we have the correct shaded region that's here. All right, let's take a look at number 2. This has 2 parts to it. I want to give you guys time to go ahead and graph these. I'll give you a hint. That first one, linear inequality, does need to be put in slope-intercept form, and be very careful as you do that. So pause the video and go ahead and see what you come up with for graphing these. Okay, if you still need more time, pause the video again. So for this first linear inequality, I'm going to move x to the other side, but my y is still negative. So I get a negative y is less than or equal to negative x plus 2. Now here I need to divide by a negative 1, so my sign is going to flip, change direction here. So I'm going to get y is greater than or equal to negative x divided by negative 1 is a positive x, and then we get a minus 2. So let's go ahead and graph that. Negative 2 is my y-intercept. I have a slope of positive 1. This would be a solid line. Now for x is greater than negative 2, this is going to be what type of a line before I sort of give it away? It's going to be a vertical line. It's also going to be a dashed line. And then the third line here, this is y is less than or equal to 3. What kind of a line is that going to be? Hopefully we're thinking horizontal line. It's also going to be a solid line. All right, so going to x is greater than negative 2, I'm going to have a dashed line going through negative 2 on the x-axis. Now let's go ahead and kind of write in where the shading is going to go. So for the first line, y is now greater than or equal to, so I'm shading on this side of the purple line above it. For my vertical line, I need to shade to the right of it. And my horizontal line is going to be a solid line, as I just mentioned. We go to 3 on the y-axis. So there's my y is less than or equal to 3. And we're going to be shading below. All right, so I need to shade below the blue line, above the purple line, and to the right of the green line. So that puts me, notice how they form a triangle, that should put me everywhere inside this triangle. That is my solution region. All right, so we're going to go ahead and find the coordinates, because we created this triangle, coordinates of the vertices. Do you guys remember what vertices of a polygon are? Where the lines, the sides intersect. So we have 3 vertices of this triangle. Go ahead and write out the ordered pairs. You could either put them right on the graph or just right underneath part B here. Let's take a look at this rightmost point. So if we count it over, that looks like we're counting over 5 and up 3. So 5, 3 is one vertex, ordered pair of a vertex. Let's go with this point here in the second quadrant. Looks like we're going 2 to the left and 3 up, so negative 2, 3. And then this point down here, looks like we're at a negative 2, negative 4. And this is going to come into play with what we're going to do tomorrow and on Monday, and a little bit in our next example. So everything boils down to application problems. We do all the practice and then we sort of apply it. So this is why I had you guys print out the notes for today. So here's the scenario. Bottled water and medical supplies are to be shipped to survivors of an earthquake by plane. Each plane can carry a total volume of supplies that does not exceed 6,000 cubic feet. Each water bottle is 1 cubic foot. Just think of a big container of water. I know we think of a smaller bottle, but we're looking at a larger container, is 1 cubic foot. And each medical kit also has a volume of 1 cubic foot. Each plane can carry no more than 80,000 pounds. The bottled water weighs 20 pounds per container, and each medical kit weighs 10 pounds. We're going to write a system of 4 inequalities that describes the situation. So I just want to give you guys time to think about it, kind of look back at the 2 examples we just did, and see if you can use something similar to those for this. So pause the video to see what you come up with. All right, anytime we need to set up a word problem or inequalities or equations, we need to represent our variables. So I'm going to let x represent the number. We know how much space a water bottle and medical kit take up. We know how much they weigh, but what we don't know, what our question is eventually going to be, is how many of each type of supply can we bring on board. So I'm going to let x equal the number of water bottles, and I'm going to let y equal the number of medical kits. So we're talking about how many of each type of supply we can have here. So if we think about this, and we have to bring in all aspects of the problem, we know we can't have any negative numbers, right? So I know I could set x has to be greater than or equal to 0. Because it is possible, even though we want to get a certain amount of each type of supply on board, it is possible to have no bottles of water. Likewise, y also needs to be greater than or equal to 0. So when we go to graph, this kind of tells us we have to be in the first quadrant because we're dealing with positive amounts here, or whole numbers. So we have to be in the first quadrant. All right, the other 2 inequalities are going to come from each little description here. So one, we're going to talk about how much space we can have in the plane. So I know the size of each water bottle is 1 cubic foot. So 1 cubic foot for every water bottle we have. So 1x, or x, plus we also have 1 cubic foot for a medical kit, so 1y. Now it cannot exceed 6,000 cubic feet. So what do you think that means? Could we go over 6,000 feet or 6,000 cubic feet? Does that mean exceed, or do we have to stay below? So we have a max capacity of 6,000 cubic feet. So we definitely have to stay less than. We could reach it, so less than or equal to 6,000. Now each plane can carry no more than 80,000 pounds. The bottled water weighs 20 pounds per container, and each medical kit weighs 10 pounds. So what do you think that could look like for x? Each bottle of water is going to weigh 20 pounds. So if you were thinking 20x, you were correct, plus, and that would be a 10y. And do you think it would be the same, no more than 80,000 pounds? We definitely have to stay below 80,000, or we could be right at 80,000. So here's our system of 4 inequalities based on what the problem was giving us. Now we're going to go, let's just go to Desmos, and we're going to type in these 4 inequalities. Okay, so pause the video if you still need to go to a Desmos app. But what we're going to type in here, we're going to have x is greater than or equal to 0. Now notice what that graphed here. So we could kind of move this around a little bit. Let's go to another line. We want y is greater than or equal to 0. And then we can take a look. So right now we know we're focused in the first quadrant. And we also want x plus y that was less than or equal to 6,000. Now this isn't going to show up right away. I'm going to have you adjust your screen here in a little bit. And then we have 20x plus 10y and that was less than or equal to 80,000. All right, so what we want to do, if you go to this little tool in the upper right, go ahead and hit that. And right here at x-axis and y-axis, let's go ahead and make that a negative 1,000. And let's make it a 5,000 for the x max that's right here. Then go down to the y-axis, make that first number a negative 1,000. And then let's make the y max here 10,000. All right, so now we see this right here is our y-axis, this is our x-axis, so we see this area right here is the overlapping region. So what we're going to do is we want to find 3 different combinations of water and medical supplies that can be taken on the plane. So I want you guys to sit and think about this, come up with some values that you think based on our work so far with linear inequalities. If you notice, all of these are solid lines. So what we could do, if you need to pause the video to think a little bit more about this, feel free. All we have to do is pick a point somewhere in the middle. So I could choose maybe 1,000 bottles of water and 2,000, because there's a nice ordered pair right here, 1,000, 2,000. So I could take 1,000 bottles of water and 2,000 medical kits. I could take maybe 3,000 of the water bottles and 2,000 medical kits. I can do 2,000 of each right here. I can go even in the middle. Anything, any point that's in the shaded region. I can even pick a point that's right at a vertex right here. So I could pick 2,000 water bottles and 4,000 medical kits. If I wanted to, I could say this plane's not going to have any bottles of water. It could have all 6,000 or all medical kits. That would total 6,000. Even over here, I could say there's no medical kits, and then I could fit 40,000 bottles of water. So any point that's either on one of the lines that borders the shaded region, or any point that's going to be in the middle of that. All right, so your assignment today, there's just 5 problems off of this Systems of Inequalities worksheet 2. Instead of having it on the next page, as always, guys, I'll have it posted as a separate PDF. And just to point out, there's going to be an individual team assessment next Tuesday. So what that means for everyone in class is they're going to work 20 minutes on their own and then 20 minutes with everyone at their table. For my students that are remote, you guys can just have the full time, since you're just going to be working on your own, I'll let you use your notes. So in that case, it's sort of an individual assessment, but with resources that you can use your notes. All right, so as always, take care. Let me know if you have any questions.